Good morning, class. In the video today, we are going to look at graphing both the sine wave and the cosine wave. We're going to be referring to these general equations, y equals a times the sine of b theta plus c, and y equals a times the cosine of b theta plus c. The values a, b, and c in these equations represent constants, and they affect the amplitude of the graph, the period of the graph, and the phase shift of the graph. So what we're going to do is, on the same axes, we're going to be graphing both a sine wave and a cosine wave. Now these have theta as the independent variable. So that means theta is going to be on the horizontal axis. The dependent variable is y. Now when you graph sine waves and cosine waves, sometimes in this spot right here you would have an x, and that would mean that you should put an x here. Or you could be graphing with time as the independent variable, particularly those of you in electrical engineering. You may have time as the independent variable, so that would dictate that you put your t here. But the ones that we're doing have y versus theta. Okay, so we're going to get started with question 1. We have 2 times the sine of 10 theta minus 20 degrees and 2 times the cosine of 10 theta minus 20 degrees. So the first thing we're going to do is identify those values of a, b, and c. So the value of a in our equation is 2, okay? The value of b in our equations is here, 10. So b is 10. The value of c, when you take the value of c, you must also take the sign that precedes it. So c is negative 20 degrees. Okay, so that's our c value. All right, the value here, the a value, determines the amplitude of the graph. So this number represents the maximum distance from the resting position. So in other words, it means that the graph will reach a maximum value of 2 or a minimum value of negative 2. Okay. So now the value of b helps you determine the period of the graph. The period is calculated by taking 360 degrees and dividing it by b. So in this case, we take 360 degrees and we divide it by 10. Okay, so that's going to give us a period of 36 degrees. What does this mean? This means that one cycle of the graph is completed within 36 degrees. Okay, so that's what that number represents. All right, the last calculation we need to make is for phase shift. And phase shift will be present when the value of c is non-zero. To calculate phase shift, you use the formula, the negative of c divided by b. Okay, so in this case, we're taking the negative of, now c is negative 20 degrees, and b is positive 10 degrees. So we end up with a positive answer here. It is positive 2 degrees. So this corresponds to a shift to the right of 2 degrees. So our graph will not be starting right here at the origin, but rather 2 degrees to the right of the origin. Okay, so I'm going to show you a nice way to figure out what we call the 5 critical points on the graph. And it goes like this. The first thing I would do is start by assuming there was no phase shift. So pretend that C was equal to 0 and set up your 5 critical values for theta. So if there was no phase shift, the graph would start at the origin and it would end at 36 degrees. And when I say it will end there, what I mean is one cycle will end there. But of course, the graph continues on in both directions. But anyway, so what I mean is from 0, and then the 5th value would be 36 degrees. So this would be the start point and the end point of one cycle of the graph if there was no phase shift. So let's figure out these other 3 critical points. We'll do the one right here in the middle first. So what number is right in the middle between 0 and 36 degrees? It's 18 degrees. So you can simply do 36 degrees divided by 2 equals 18 degrees. Okay, and then to find the number directly between 0 and 18, you just divide this number again by 2. So 18 degrees divided by 2 is 9 degrees. And then the last number we need is directly between 18 and 36. And one nice way to figure this out is just to add 9 and 18 together, and you will get 27 degrees right here. So these would be what I'm calling the 5 critical points if there were no phase shift in the graph. Okay, so again, start with 0, end with this value, the period length, divide it by 2, divide this number by 2, and then you can add these 2 to get this one. Notice that these are all 9 degrees apart now. 0 plus 9 is 9. 9 plus 9 is 18. 18 plus 9 is 27. 27 plus 9 is 36. Okay? Now, there was a phase shift because C was non-zero. C was negative 20. The phase shift is 2 degrees. Positive 2 degrees corresponds a shift in all of these numbers to the right 2 degrees. Okay, so when the sign in here is negative, the shift ends up being to the right. Okay, so how do I shift all of these to the right 2 degrees? I simply add 2 to all of these. So we're doing 0 plus 2 degrees, 9 plus 2 degrees, and so on. So we will get these new numbers: 2, 11, 20, 29, and 38 degrees. So these are the numbers I'd like to show on this horizontal axis, and they're the only numbers I'd like to show there. Notice they are also, each one is 9 degrees away from the other one. When I go to graph these, I want to start a little bit to the right of 0. So I'm going to say right there is 2 degrees. And now I want to make sure I put these equally spaced. So I'm putting down my ruler and I'm going to go 2 centimeters here. Okay, like this. Look, can you see the ruler okay there? Probably. So I'm going to put a little marker here every 2 centimeters till I have 5 markers. Okay, and then I'm going to write the numbers here: 2, 11, 20, 29, and 38, just like that. And now I'm all set. I'm ready to sketch the graphs. Okay, so I'm going to use two different colors to sketch these graphs now. So I'm going to start with purple, and I'm going to draw the sine wave. The sine wave. So when you go to graph the sine wave, once you have the 5 points written down, you're always going to put the first one, the third one, and the fifth one right on the line like that. And then all you have to figure out is whether at 11 degrees you should be up at 2, or at 11 degrees you should be down at -2. And this is always based on the value of A. So A is +2, so we actually make sure our wave goes up first, which means at 29 degrees we'll be down here like this. And then just no ruler when you connect these because it's a wave. So you just make your wave. Now smooth like this. Show the line extending a little beyond each of these points, just as a reminder that this is cyclical. Okay, and that's it. That's the sine wave graphed. Okay, so how is the cosine wave different? So I'm going to use a green pen now and show you. When you do the cosine wave, instead of the first, third, and fifth points being on the axis, you put the second and fourth point on the axis. Now remember, we had a positive A value, so the graph should be at its maximum first. So that means at 2 degrees, we will be up here at the maximum value of 2. At 20 degrees then, okay, so it's going like this, right? At 20 degrees, you'd be at the bottom. Then you're gonna come back up, and at 38 degrees, you'll be back up here. Okay, so smooth curve again. There's the maximum through the 0. There's the minimum through the 0. And there's the maximum. Okay, so I'm going to label the curves now. So this one is, I'm just going to write cosine. And beside this one, I'm just going to write sine. And you can see how the graphs are related. In fact, we say that they are out of phase 1/4 of a period. All right, they're 11 degrees in this case out of phase with each other. Okay, which corresponds to 1/4 of the period. Great, so what I'd like to do now is a second example. So we'll put that one aside. Hopefully you can see that well. Let me take a look at the camera. Think you're okay? Okay, let's do a second one. So exactly the same objective. We're gonna sketch both the sine and the cosine wave. The equation is negative sine 1/2 theta plus 5 degrees, or negative cosine 1/2 theta plus 5 degrees. So how do we begin? We begin by saying what the value of A is. Now remember, A, you can look back at the general form if you like. A is the coefficient here. So in this case, all we have is this negative sign. And of course, that corresponds to A equal to -1. The value of B, again, you could look here, is the coefficient right here inside, the coefficient of theta. So in this case, B is 1/2. And C, remember, is here in the equation. You have to take the sign in front of it. So it is a positive value this time. It is positive 5 degrees. Okay? Last time we had -20 degrees for C. Okay, now we need to make two calculations. One for period. The formula is 360 degrees divided by b. So here it's 360 divided by a half. When you take 360 and divide it by a half, you're going to actually get 720. So that's the length of one cycle. If there was no phase shift, the graph would start right here at the origin, and one cycle would be done in 720 degrees. Phase shift. The formula is the negative of c over b. So in this case, it's negative of 5 degrees divided by 1/2. And negative 5 divided by half is negative 10 degrees. Okay, when the number here is negative, this is going to mean a shift in the graph to the left. Okay, so when the sign in here is positive, the graph actually is shifted to the left of the origin. Okay, let's come up with our 5 critical values. So first, we come up with the 5 critical values, assuming no phase shift. Then we'll shift all of those values 10 degrees to the left. Okay, so I begin. If there was no phase shift, the graph would start at 0, and then the 5th critical point would be 720 degrees. Okay, now I'm going to find the value right here. So I do 720 degrees divided by 2 equals, and that is 360 degrees. And then I do 360 degrees divided by 2, and that is 180 degrees. Now I add these two values together, and I get 540 degrees. But those are not the numbers I'm going to put on the axes, because I have to take the numbers and shift them all to the left 10 degrees. Okay, so this time we're shifting to the left. So what I have to do is take 0 and subtract 10 degrees from it. Take 180 and subtract 10 degrees from it, and so on. And these are the numbers I want now on my graph. Okay, so I'm going to turn to the graph now. Make sure you label your axes like this. What numbers should I show here on my vertical axes? The value of A is 1. Actually, it's -1, right? The value of A is -1. That means the amplitude is 1. Okay, amplitude is distance from the horizontal axis, maximum distance. So we always use a positive number to represent a distance. So we say that the amplitude is 1, but the value of A is -1, and it means I need these values on my vertical axis. Okay, now I'm ready to show these 5 numbers on this axis. The first one has to be slightly left of 0. So here, okay? And then I'm gonna do the same thing I did last time to make sure that I'm showing that the distance between each of these is exactly equal. So I'm gonna go with 2 centimeters again, like this. Okay, and so these are the numbers here: -10 degrees, 170 degrees, 350 degrees, 530 degrees, and 710 degrees. Those are the numbers I would like to show there. And now I'm going to draw them, and I'm going to use the same color scheme I used for the last example. So we'll start with sine. So there are 5 critical points here. For the sine wave, we put dots here, here, and here to begin with. The first, the third, and the fifth. And then all I have to determine is whether it goes up first or down first. And remember, we do that by looking at the value out front. It is -1. So the graph actually goes down first, and therefore it won't be at its maximum till right here at 530 degrees. Smooth curve. Great. Now I'm going to go with green for the cosine wave. For the cosine wave, start by placing these 2 dots, always. And now, again, it's going to be down first. So that means at -10 degrees, it'll be down to -1. It won't be at its maximum till this middle point, back through 0, and then it will be at its minimum again at 710 degrees. Okay, just like that. And again, there's a phase difference between these graphs of 180 degrees. The green one, once again, is cosine. The purple one is sine. All right, so I hope you see how that was done. Sine has the first, the third, and the fifth points as the zeros. Cosine has the second and fourth points as the zeros. Okay, maybe we'll just do one more together to make sure you're all solid with this, okay? One more. Then you can try some on your own if you like. All right, so last one here. We've got our 2 equations. We're gonna say the values for A, B, and C. Okay, so the value of A is -4. The value of B is 1/4. And C is negative. It is -125 degrees. Okay, I'm going to label my axes just like this. If I want to, I can now put these points on my graph as well, on my axes here, because I know the amplitude is 4. It means on the graph I'm going to need a 4 and a -4 shown. And again, look, see how I've done this 2 lines up, 2 lines down. You know, you wouldn't put 4 up here 3 lines away from the horizontal axis, and -4 only 2 lines away. You want to make this spacing equal this spacing as well. Okay, let's do our calculations. Period 360 degrees divided by B, which is 360 degrees divided by 1/4. So this is 1,440 degrees. So again, what does that mean? It means the graph would go through the 5 critical points between 0 and 1440 degrees if there was no phase shift. So if there was nothing here after the theta. So if the equation was just -4 sine of 1/4 theta, for example. Okay, let's do the phase shift calculation as well. The negative of C over B, so it's the negative of negative 125 degrees divided by a quarter. So this is going to be positive, oops, sorry. This is positive, right? So we end up with positive 500 degrees. Okay? So this is going to correspond to a shift in the right. So again, remember that. It's kind of counterintuitive. When the sign in here is negative, you actually will end up shifting your graph to the right. Okay, so let's come up with the five original numbers. So they would be from 0 to 1440 if we had no phase shift. 1440 divided by 2 is 720. 720 divided by 2 is 360. 360 plus 720 is 1080. And now we introduce the phase shift. So each number is now shifted 500 degrees to the right. And therefore, to account for that, we just add 500 to each and every one of these values. And we're going to get this. Okay? So these are the values we actually would like to show on our axes. Okay, so the difference between each of these is 360 degrees. So I have to start 500 degrees to the right. All right, so I'm gonna say that that's 500 degrees, and then I'm gonna show these numbers here. So this is 500, 860. So what I did was I put 2 centimeters in between all of these, and I just made this a little bit more than 2 centimeters because 500 is more than 360. Okay, so I'm not too worried about this being to scale, but make sure again the spacing between these numbers needs to be equal. All right. So now I'm all set to make the graph. I'm gonna start with purple, which is the sine wave. So I put my dots here, here, here. So should the graph go up first or down first? A is negative, so the answer to that is the graph goes down first. So at the second point, it will be up to its maximum here at 1580 degrees. Sketch. Okay, like that. And then to make the corresponding cosine wave, we start with dots here and here at the second and fourth points. Once again, at this first point, we have to decide whether it's up here or down here. The A value of -4 tells me it's down here. So down through 0 at 1220, it'll be at its maximum. And back through 0 and to its minimum at 1940. And then again, smooth curve. Perfect, just like that. So this one is cosine, green. This purple one here is sine. Okay, so that's 3 examples for you. I hope that wasn't too bad. Please take a look at Blackboard for the recommendations for practice. Have a great day.